Welcome to the lesson on manual production lines. Upon completion of this lesson, learners will be able to describe manual production lines by evaluating their characteristics, advantages, and limitations. They will be able to explain the importance of cycle time analysis for production efficiency and resource planning. Through practical application, learners will demonstrate the ability to apply cycle time equations. Learners will also be able to list and describe the sequential steps involved in the manual production line. Though machines are a valuable tool in production, some products require human touch to achieve certain assembly processes. So, how can a company efficiently produce products that are manually created? There are various steps involved in effective manual production. A manual production line is used for manufacturing assembled products in large quantities by hand. Manual production lines are sometimes called assembly lines. Automobiles, trucks, consumer electronic products, appliances, and power tools are examples of products assembled through the use of manual production lines. The workstations within manual production lines are designed in a sequential manner. The most common operations performed in manual production lines include mechanical fastening, spot welding, hand soldering, and adhesive joining. Human workers perform the operations within manual production lines. Let us discuss some of the key concepts in manual production lines. At the start of a line, the worker performs an operation on the base part. The base part is the first part of the final product to be processed in the assembly line. The operation completed at each workstation involves the addition of components to the base part. The base part is carried to the next workstation by a work carrier after the worker has completed the first operation. The work carrier is passed on to the next workstation by a conveyor. The worker at the next workstation will add more components to the base part and then pass it on to the next workstation. The base part exits the final workstation of the assembly line as the final product. First run or first production run is the first set of products that are made by a production line after their setup. Industries aim at setting up their production line to produce a high-quality first run that meets customer specifications. Advantages of a high-quality first run include little or no need of testing products after production and decreased production costs as a result of minimal rework. If the customer needs and specifications are met in the first run, all subsequent runs will follow the first run's production line setup. One step in the planning phase for manufacturing a product includes analysis regarding the number of products that need to be produced to meet customer demand along with a schedule for the delivery of those products. This planning must determine the appropriate number of workers and workstations that must be allotted to the manual assembly line to meet the demand and schedule. Cycle time analysis is performed to determine the number of workers, shifts per week, hours per shift, and workstations required to meet the demand for product within the agreed-upon schedule. The equations shown on the next slide are used in cycle time analysis. The equations shown here are used in cycle time analysis. The average production rate for a manual production line can be represented by the equation shown at the top of the table. RP in the equation represents the average production rate in units per hour. dA in the equation represents the annual demand for the product in units per year. SW in the equation represents the number of shifts per week, and HSH represents the hours per shift. Cycle time, TC, provides an estimate of actual production time while factoring in reliability issues, which can include mechanical failures, electrical problems, and power outages. Efficiency, E, is expressed as the ratio of uptime to total time, emphasizing the importance of minimizing downtime and maximizing uptime among the production team. TP, the average production time, is calculated by multiplying the reciprocal of the average production rate by 60. A production line must operate at a faster pace than TP to meet the annual demand for the product. Cycle time is calculated by multiplying efficiency with average production time. To meet annual demand, the average production time, TP, must be faster than TC. Each product requires a specific completion duration known as work content time, or TWC. The minimum number of workers required for production can be calculated by dividing TWC by TC, yielding WMIN, which represents the minimum workforce needed. Also, the number of workstations required is influenced by how many workers are assigned to each station. Let us consider an example of cycle time analysis using an EV battery pack assembly line. An electric vehicle manufacturer is planning a new battery pack assembly line. The goal is to help them determine the production line requirements based on the following information. The annual demand target is 50,000 battery packs. The operating schedule is 50 weeks per year, 2 8-hour shifts per day. Line efficiency is 92%, accounting for quality checks and complexity. Basic process time is 45 minutes per battery pack. Total work content is 280 minutes, which is broken down to cell inspection and testing, module assembly, pack assembly, thermal management system, BMS integration, and final testing and quality check. The calculated results are shown here. The average production rate, or RP, is calculated as approximately 1.25 packs per hour, which totals 20 packs considering the 16-hour shift. The cycle time is calculated to be 41.4 minutes. The minimum number of workstations required is calculated as 6.76 rounded off to 7 workstations. Now, the annual capacity per line is 20 packs per day multiplied by 5 days per week times 50 weeks, which equals 5,000 packs. In order to meet the annual demand of 50,000 units, the number of parallel production lines required is 10. With 10 parallel lines producing 20 packs a day each, the daily production is 200 packs, weekly production is 1,000 packs, and annual production is 50,000 packs. When it comes down to it, meeting deadlines yields happy customers. Communicating something as simple as a deadline is important throughout all levels of the workforce. From shift-to-shift workers to managers, in a fast-paced environment, a system should be in place to communicate customer demands. For example, software vendors have developed a number of systems to streamline communication between suppliers and customers and within production lines. This type of software has functions that can be used for checking customer inventory, monitoring logistics information, and generating instructions for warehouse management. Technology is used nowadays for replicating physical processes such as Kanban, a card-based system for signaling events within the production line. All of these new technologies ultimately meet the common goal of communicating and fulfilling customer needs. In summary, a manual production line is used for manufacturing assembled products in large quantities by hand. Cycle time analyses help to minimize downtime and maximize uptime. Cycle time analyses are performed to determine the number of workers, the shift per week, the hours per shift, and the number of workstations. Meeting deadlines is important for customer satisfaction and effective communication. Thank you.